Today, I want to talk about my project, analyzing telematics data to support the connected car industry. First, let me introduce my background. I have been a software engineer for about 10 years since 2007, when I was in China. At 2017, I began my master's degree of computer science at Georgia State University. Last year, there was a project about gene analysis of omega bioinformatics using HPCC system with Dr. Meng Han at Kansas State University. This year, I'm an intern and work for NextNexus from August to October. This project is helping the insurance company to customize the price for their clients based on their driving habits. What was the average auto insurance cost in the United States for the year 2016? Here are 4 options. First, $735, to $835, 3, $935, 4, $1,035. You will get the answer from my following slide. Here is a brief outline of today's presentation. I will do the introduction and tell you why we need to do such a project, how we do, and what's the result we have found in our project. First of all, we all know accidents increase year by year due to more and more cars on the road and a growing population. However, we should note many drivers with good habits are providing with high insurance fee. Some drivers with high risk get the low insurance fee. It's unfair to all of them. For different people, we should provide different price. With more and more data, we should get more value. We can customize the evaluation for all the people. It will best benefit the insurance customers as well as benefit the insurance company. It's well known that accidents increase year by year. From the left chart, you can see the total number of the traffic accidents in the United States increased about 25% from 2010 to 2016, which includes the fatal accidents, injury accidents, and accidents. At the right picture, the average auto insurance fee has increased around 20% from 2008 to 2016 for National Association of Insurance Communities. However, it's not an easy question since we got more and more data from many resources. How to precisely data, how to leverage the pattern of the data is still very, very challenging. We, our HPCC system, are super good at precising the data, provide the value for our customers, such as every insurance company. So here in our project, we developed a one-stop pipeline to precise the driver habit data. Based on this data, we can do analysis to each driver and provide the best model based on the driver habits. Here is the architecture of our project. This project separated to 3 parts: the simulated telematics system, cascade message queued, and the HPCC system. Telematics system will generate hundreds or thousands of threads and zip codes by multiple threads. They will read the telematics data from the data set and deliver the data to cascade message queue separately. After the message is received by cascade message queue, another ECL program at the HPCC system will fetch the data and the cascade message queue, paste and save them to the database. After that, another ECL programs will analyze the data and send the results back to our clients. After we have acquired the telematics data, you will begin to the ECL process. It's quite important to understand the meaning of each column in the data set. This will help us to find the key columns for the whole data set. After locating the top columns through previous steps, start statistics these properties by grouping the key columns. This is a vital point, and the whole process, as is known to all, it's impossible to enhance all the properties in the data set. Therefore, the more time you spend on this step, the less likely deviation the model will be. In the left two charts, the unique column is the device ID, or we can say car ID. The CNT column in the first picture means total driving time for the car. At the center graph, the CNT trip column represents total trips for the car. The AVG trip time column indicates the average time per trip per car. The primary key for the right chart is device ID and trip ID. Acceleration GPS column shows the acceleration based on GPS speed. Acceleration RPM column means acceleration based on RPM. Here, I will introduce two important concepts to our project: hard acceleration and heartbreak. Hard acceleration you can see at the left graph, and heartbreak you can see at the right picture. As driver events, then more force than normal is applied to the vehicle accelerator or brake system. It can be an indicator of aggressive or unsafe driving behavior. At the very least, this driving habit is wasteful and uneconomic. There is no optical definition to the threshold of hard acceleration and hard brake. Here, I choose the most common threshold to record a hard brake or a hard acceleration, 7 miles per hour per second, or it will keep the equivalent to 10.2 feet per square second. Here is some graphs from our demo. We process more than 1 million trip data of 10,000 vehicles in a period of 180 days. There will be 4 to 7 trips a day for each vehicle. The extension in the day of all the days is no more than 180 days. Different drivers have different driving habits. After the messages are received by Kafka message queue, an ECL program of HPCC system will fetch message data from Kafka message queue periodically and paste these messages to the required format. In the unnecessary data, save them to the data set as graph shows. The following is some result we got from the AWS cloud. Here is one example of our analyzed results. The hard acceleration and the hard brake are the two key features to the car essence. The left graph shows different drivers and their average hard acceleration time per hour. The x-axis means different vehicles. The y-axis means the average hard acceleration time per hour. In the right picture, it presents different drivers and their average hard brake time per hour. The x-axis means different vehicles. The y-axis means the average hard brake time per hour. We can simply get the result that driver 1110 and 1116 are the worst drivers in these 8 drivers. The total trips and total driving hours are the two implement features to the driver habits. The left graph shows different drivers and their total trips. The x-axis means different vehicles. The y-axis means the number of total trips. In the right picture, it presents different drivers and their total driving hours. Depending on the trip data and the threshold, the analyst can help our client to identify the good or bad habits when driving. I developed this data pipeline, data processing of the project to a whole solution from scratch based on the back end as a software engineer. With the support of our HPCC team, I got the opportunity to improve the performance of our project efficiently and effectively. Initially, the running time for the data generation, data processing, and data analysis is very, very high. After several times of optimization using multiple threads, decreasing the steps for iteration, change, the running time of data generation, data processing, and data analysis has decreased by 82% to 96%. In summary, our project addressed the problem to customers' price in the insurance industry. Based on the driving habit, we implement a precise data pipeline. We provide deep insight into driving habit to model the rates for different drivers. As shared, we provide a comprehensive one-stop solution for the insurance industry. Do you think this model using HPCC system may help decrease your insurance costs? There are two options. First, yes, it will help the insurance company to implement their model and decrease the fee for good drivers. Second, no, the model of the insurance company is quite perfect. They will not decrease anymore.
All right. Wafu, thank you so much. That is such an interesting presentation, and I've seen your poster on it and now your presentation, and it's so interesting. So while you take a look at the questions that have come in from the audience, we're going to take a moment to look at your poll questions. Now, the first one we're going to need your help for, Wafu. The question was, what was the average auto insurance cost in the U.S. for 2016? And half of the people picked $935, and the other half picked $1,035. What's the right answer?
Yeah, I think everyone got the right answer. It's $935. You can see from I remember in the graph, in my graph, there has a lot of the results. But you can see the last result is $935.
All right, fantastic. All right, we'll give people a little bit more time to vote on your last poll question on whether they think it will reduce their auto insurance. And let's go ahead and take a peek at the questions that have come in from the audience. If you can take just a second and prioritize those for me.
Oh yeah, the second question is do you think the model using HPC system may help decrease the insurance costs? I remember there are two answers. First is it will be yes. You will help the insurance company to implement their model and decrease the insurance fees for the good driver. Second is no. The model for insurance company is quite perfect. The insurance fee will not change at all. In my mind, I think both are possible. If you are a good driver and drive very carefully, I consider the first one has much bigger possibilities. Yeah.
So it's up to us then. All right, perfect. All right, let's take a quick peek at some of the questions from the audience. So the first one is, as you mentioned, your system can be adapted to other systems. Could you explain a little on how to adopt it into other systems and which kind of projects would be better for the optimization?
Oh, yeah. As I mentioned before, I have all the optimization programs, all the similar data sources, no matter the car data, weather data, or plane data, or other complexity data, will be proper to fit for the solution designed to be optimized. In summary, our solution has optimized in the data generation, data processing, and data analysis. At first, it utilized multiple threads to enhance the performance. For generation data. Second, it has optimized the string of Kafka message queue. Last but not least, it optimized the iteration and normalization for extract the key filters and the data analysis. You can see the key filter. This contains hard acceleration and Heartbreak in my project. Every project similar to my project, such as Telematics data, smart car data, and other similar projects, could be applied to my solution and optimize them.
All right.
Hi,
thank
Lauren.
you. All right. So let's take a look here at this next question. How much performance have you improved for the whole system?
Oh, good question. The total running time has decreased about 89% compared to initial. Also, we using multiple thread, we using change, and it will increase a lot. And our solution also can apply to other systems such as Telematics system, smart car system, and so on.
Okay.
Hello?
It looks like there's another question in here about on data of scale and what the challenge is of working with data on scale.
Can you say it once? Hi, Lauren.
So,
can you say it once?
Yes. So the question is, what is the challenge on working with so much data, with that scale of data?
Yeah. Quite good question. The challenge for our project is it has millions of trips. How to use this data to generate the model, how to extract the key features to our system that relate to the driver habits, how to increase the performance. That's quite challenging to all of us. I simply all the data to extract two key filters. You can know that in our system we have the Heartbreak and hard acceleration. That's the two key filters to the car accident. That's the key filters I extract.
Okay, thank you.
All
right. It looks like there's another question that's come in, Wafu. Just talking about the next steps for this project. So I know you're an intern and your project has ended. But where do you think this project could go?
Oh yeah, I remember that my manager told me that my project will be used by another insurance company and you'll be quite large. They require about 5 million cars per 5 million car trips per week, and you need to connect the data. because every day at the peak is about in 10 minutes. You need to run about. I remember it's more than 1 million of a trip. That's quite a challenge. You need to my system. It can be from the first side. It has multiple threads. Second, it has clustered. In our demos, we only have about one front end server, one back end server, and one cluster in our HPC system. All the parts will be enlarged. And for the front end, it will be enlarged to about more than about 10 clusters. For the HPCC server, it will be enlarged to about 20 clusters to 30 clusters. The third is the Kafka message queue. You at least need to be enlarged to about 10 to 15 clusters.
Wow, that's amazing. That's amazing. It sounds like you've laid a very solid foundation, Wafu. Thank you for that.
All
right.
Thank you.